as x goes to 1, of x squared minus 1 over x minus 1, the first thing we try to do is plug in, and when we do that, we get 0 over 0. And remember, this guy is called the indeterminate form. And that means you cannot determine what's happening on this graph. 0 over 0 means there could be a hole, there could be an asymptote, there could be a jump. We need to investigate, we need to do some more work. One thing we do know, though, is that if we plug in 1 and get 0, then x minus 1 has to factor out of the top and the bottom, because we got 0 when we plugged into both of them. So basically, this is one of our factoring limits. Limit x is going to 1. The top is going to factor into x minus 1 times x plus 1 over x minus 1. So these are still the same thing here. Okay? Now, we're going to use our limit rule 2 here, our very important rule 2, which says that there's just a hole in this graph. So this graph right here, this x minus 1, let me block this off. This graph right here, this x minus 1 times x plus 1 over x minus 1, looks just like this graph, x plus 1, except for where x equals 1. X can't be 1, because if x is 1 and x plus 1, then we get 2. But if x is 1 down here, we get 0 over 0. Okay? So the functions don't agree at one point, 1. However, our limit rule number 2 says that if two functions don't agree at just one point, then the limits have to be equal. So what we're going to do is trade in this limit here of x minus 1 times x plus 1 over x minus 1 for just x plus 1. So essentially, yes, we're canceling these things out. Okay? But again, the reason it works is the graph of this original function looks just like the graph of x plus 1 everywhere except for at 1. So this limit's going to be 2. Now graphically, let's draw a little graph. This is what's happening on this graph. X plus 1 looks like this function right here. Okay? And at 1, we have this point, 1, 2. So x plus 1 looks like this line here. Well, so does x squared minus 1 over x minus 1. They look exactly the same. This function looks just like this function, except for at 2. At 2, we really have a hole. So our graph is going to look like this now. This is what our graph really looks like. It looks just like x plus 1, but there's a hole at 1. However, both sides of this thing, as x approaches 1, both sides are approaching that hole, which has a y value of 2. And that's why we get the same answer.